10.3 in Advanced Algebra 2. Last time was arithmetic sequences and series. Today, geometric. Arithmetic had a common difference. Geometric, you should remember from that video after the test, there's a common ratio. They keep multiplying by something. Or you could think of it as dividing, but if you wanted to divide every term by 3, it's the same thing as multiplying it by 1/3 every single time. There's an explicit formula, the nth term of a geometric sequence. Remember, we try to use the letter G instead of the letter A for arithmetic, G for geometric. It'll be the first term times that common ratio to the n minus 1 power. And then the recursive formula we'll deal with today also. It's the same concept. You'll do the two situations. You got to know the first term. The nth term will then be that ratio times the previous term for all integer n's greater than or equal to 2. So let's check this out. Find the next 3 terms in the geometric sequence. Here's the first term, second term, third term. What do we got to know before we can find all these terms? What that ratio is, right? How do you find it? Take any term divided by the previous term right before him. So let's take 480 divided by the 1200. If you get a decimal that's clean like that, we'll just use it. Let's jot him down that our common ratio is 0.4. Cool. And now let's find the next term. Don't we need to take that 192 times 0.4 and get 76.8? And then what would you do to find the next term? Take that times 0.4, right? 30.72. And now your calculator is ready to rock. If they wanted more terms, don't we have that previous answer, right, times 0.4, so just hit equals again, and you get 12.288. That's 1, 2, 3, 4, 5. That's the 6th term in the sequence. Here's the 7th term, 8th term, 9th term, 10th term, etc., right? That's like your recursive formula right there. It's always the previous term times that ratio. Cool? The previous term times that ratio. Write an equation for the nth term of the geometric sequence. Hey, if they don't tell you which equation to write, because there's explicit and recursive, take a wild guess which one that we want to write. Explicit. Cool? So let's start with it, and then once we get comfortable with it, we can stop writing it down at the beginning. It'll be the first term times the ratio to the n minus 1 power. And all I really need to know in this one is the first term, which is right there. I need to know the ratio also. How do you find that again when it's geometric? Second term divided by the first term. Let's punch that in. Boom. Common ratio is 3. Is that what we got? So just subbing in. Any term in this geometric sequence, that's what that stands for, the nth term, whichever term you want, will be 3.6 times 3 to the n minus 1 power. So if I wanted the 17th term, I'd just put a 17 in for n, and I'd raise 3 to the 16th power, and then take it times 3.6. Feeling cool with the explicit formula. Next. For each, find g of n for each geometric sequence. So they tell me the first term, they tell me the ratio, and they tell me n. That's where we're going to start with our generic right here. Cool. We don't know the nth term, if you will. So let's let's start with the formula. And let's just kind of sub in all we know. We do know the first term, right? We do know the ratio, and we actually know the term number that we want, correct? So that means that we would write not g of n, not g sub n, but g sub 2, meaning the second term is negative 10 times 4 to the, you can do a little mental math right there and do n minus 1, which is 2 minus 1, which is to the first power, right? And then we can do mental math on this one. That's really a 4 times negative 10. The second term is how much? Negative 40. Box in. Cool. Let's start with this one again with the formula. Remember, this is on the Mint note card. I hope you check that out as we're working today so you can find those formulas where we're looking at them. You can use that Mint note card on tests and quizzes. So they want the fifth term. That'd be 8 times 2/3 is my ratio. To what power? Fourth. Now this is where we got to slow down. And using your calculator isn't going to do you much good because you get a nasty decimal out of this situation because isn't the rate a fraction? Let's do what we've always done. G sub 5 equals 8. Don't we need to take 2/3 to the fourth power? And I'll bet you know what 2 to the fourth power is without a calculator. What's 2 to the fourth power? And 3 to the fourth power is how much? 81. And you can always double check, is 81 the right number that we want right there? Yeah, 81. I just need to multiply those together. Well, let's make 8 a fraction and multiply those together. The fifth term in this sequence. 8 times 16 is how much? 128 over 81. Now let's at least use the calculator since we have him. 128 divided by 81. And I just want to see if that reduces. So how do I see if that reduces? Math, enter, enter. But you know, if you're always just math, enter, enter in without trying to do a little basic, your fraction knowledge, you will forget it faster than you even imagine. Do a little bit of work. Then I don't care if you want to clean it up by math, enter, enter in, right? But keep yourself privy with the fraction knowledge. Awesome. So it didn't reduce. So that's our fifth term in a sequence. Awesome! Do number 3 for me, please. Please pause video. Get that done. So I got it all subbed in. What will this turn out to be if I take a -1 to the 7th? A negative number to the 7th power will be positive or negative. Still going to be negative. So 1 to the 7th is 1, and it's negative. Now 2 to the 7th is how much? 128, right? Then I get this, 6 over 128. How did it turn positive? Cool. See if it reduces. 6 over 128. Math, enter, enter him. Obviously he reduces. What's he reduce to? 3/64. Cool. What do you think happens when the rate's negative? Like the first term in the sequence was a -6, correct? What's the next term in the sequence going to be if you multiply by -1/2? -6 times -1/2. So I'll start writing this down for you. The first term was -6. The second term was what? Come on, you can take half of -6 and times a negative. What do you get? 3. The third term, take 3 times a -1/2. What would you get? -3/2, right? The third term, take -3/2 times a -1/2. What do you get? 3/4. Now take half of that times a negative. What's the fourth term going to be? -3 what? 8ths. Then half of that, a to the 5th power. +3/16. Let's see if we can notice two different things that are happening. First of all, signs. Positive, negative, negative. Wow. How about negative, positive, negative, positive, negative, positive? Why do the signs keep alternating? The rate is negative, correct? Right? So aren't you going to take a negative times a negative eventually, and then a negative times a positive, and then it'll be back times a negative again, right? The signs alternate. Now, what happened with your numerators? If you just think of them absolute value-wise, what were the numerators every time? They were 3's, right? What happened to those denominators? 2, 4, 8, 16. The next one would have been a 32. The next one after that would have been a 64. The next one after that would have been a 128. What's happened to those? Those are powers of 2, right? You know, powers of 2. 3 over a power of 2. Let's jump down to number 5. Write the explicit and recursive formulas for these geometric sequences. Remember, they told us it was geometric. We need the magic ratio first. Find me R. What's the rate? 0.7, right? Explicit, label it first. If you're ready to drop that formula, you can. But I'm telling you, when things get all mixed up and you get stuck in a jam and you're kind of like, what am I supposed to do? Write the formula down first. Cool? But if you don't need to, that's you. G sub n will equal the first term. What's the first term? 500 times the rate, which is 0.7 to the n minus 1 power. Done, right? Cool with that? Recursive. The first term is 500. Then any term after that will be the rate, which is 0.7 times the previous term. And that's what that g to the g sub n minus 1 means, is that's the previous term. Is there anything else I need? I need to kind of restrict the domain on n's. So it's for what kind of n's? You don't even have to put the word all. That's fine. But for all integer n's that are what? Cool. Greater than or equal to 2, maybe. God. Then we put the bracket around it. Why are the integer n's greater than or equal to 2? Because we've already figured out the first one, right? We need to go with the next one after that. Well, what's the next integer after 1? 2. Cool. Do that for number 6 for me real quick. Explicit and recursive. Here's our explicit formula right here. It's the first term times the rate to the n minus 1 power. And my recursive, the first term is 8. Any term after that will be that rate of 4 times the previous term for integer n's greater than or equal to 2 as a bracket. Pretty simple, eh? Pretty simple. Let us jump to number 8. What's different about number 8? They give me the rate, correct, which that's cool. And what is that 324 all about? Okay, the third term. The third term means nothing to me. Now some people are like, well, couldn't you work backwards? You know, it's like if they're getting multiplied by 6 every time, how do you go back instead? Instead of multiplying by 6, what could you do? Divide by 6. But what if I gave you the 35th term? Would you want to divide it by 6 34 times to get back to the first term? Would you want to even try that? So the idea is when they don't give you the first term, why don't we use this formula right here, which is the explicit formula? Let's start by writing him down. All right, something's new, so I started with the formula. Do I know an n value? Secretly, we do. We know an n value is 3, right? Do we know the g sub n value in that situation? Don't we know g sub 3? So that goes right here. The third term is 324. Cool. Do we know the first term? Yes or no? That's what we're trying to find, so we better not know it. Do we know the rate? 6, right? And do we know n? What's n in this particular case? 3. And then we got to subtract 1 from him, so wouldn't we really put a 2 right there, right? 3 minus 1. You with me on that? Because they told us the third term, we substituted that third term in for g sub n and realized that n equals 3. You might make a note above that, above him. N equals 3. If you're not sure, they kind of told us that right there. Then we got to solve for g sub 1. Well, don't we need to square the 6 and get a 36? And then figure out the first term. The first term is 324 divided by 36, which you punched in to give me a 9. Now, you have the ingredients to write the recursive formula and the explicit formula. So, squiggle, explicit. Remember, that was the question. Please write the explicit formula and the recursive formula. We just didn't have the ingredients we wanted yet. So, explicit, the nth term will equal that first term, which is 9, times the rate. Remember, they told us that to us. Is 6 to the n minus 1 power. Hey, just for giggles, why don't we clean this up to be the nth term equals 54 to the n minus 1 power? Like, why don't we do that? Why can't we take the 9 times 6 and get 54? Because isn't 6 being raised to an exponent at this time? An order of operations does not allow that to happen. This has to happen first before you can take it times the 9. Good deal? Recursive! For all you Ricola fans out there, recursive. That would have been a fun thing to teach in the 80s. What? First term was what? Nueve. Nth term? The rate. The rate. The rate is on fire. We good with that? Piece of cake? Yes, no? That's the beauty. We kind of did all the work last time learning about explicit and recursive. Now it's just a geometric deal. Hey, what's that big fat sigma all about? What's that thing? We want to find the sum. The thing is, this right here, this is not an arithmetic situation at all. What kind of situation is it? Geometric. You can tell because it's something times a base to a power, right? You know, it's like, isn't this like an exponential situation right here? Cool. Let's do the same thing that we had to do before. Note your mint note card. That formula is on there. This is your formula to find the sum of a geometric series. So here's what we need to know. I need to know the first term that we're going to count up. Remember, a sequence goes on forever, right? I could have an infinite amount of terms in a sequence. We're only adding up a certain few of those terms. Which ones are we adding up? Well, if I listed them all in order, I want to add up the second term in the sequence through the seventh term in the sequence. We cool with that? So this really isn't the first term that we're finding in the actual sequence. It's the first term that we are starting with when we add the terms up. You with me on that? So that means we got to let k be 2 in this situation. So show me a little bit of work. The first term that we're starting with would be 5 times 3 to the, if I put 2 in for k, what's that exponent turn out to be? To the first, which 3 to the first is 3 times 5, which is really what number? 15. Awesome. Now look at this formula. Different than Gauss's formula. Like, we need the first term. Don't we have him right here? Right, that g sub 1. Do I need, excuse me, do I need the last term in this sequence? Like, do I need that seventh guy or anything like that? Or the g sub nth term, is that involved at all? I don't need him. What else do I need in this problem? I need r, right? This is the explicit formula for the sequence. Like, if we go back, see how our explicit formula is basically like this. It's got some sort of number right here times something to the blah minus 1 power. Which one of these is the rate? The 9, the 6, or the negative 1? Which one's the rate? Isn't 6 the rate in this situation? So what's our rate right here? The 5, the 3, or the negative 1? What's our rate? The rate is that base. Megan's still right. It's all about that base. You know, the rate is the base. What else do I need to know? I've found g sub 1. I found r. What else do I need to know? N. Same way. It's high minus low plus 1. What's the high number in this situation? 7 minus 2 plus 1. High minus low plus 1. 7 minus 2 is 5 plus 1 more, which is 6. Now we'll substitute in. I'm not going to write that thing down. I know what we're trying to do. We're trying to find this sum, right? So the sum of the first, how many terms do we got? 6 terms will be the first term that we started with, which was 15 times 1 minus r to the nth power, which is what power? 6, all over 1 minus r. Well, what's 1 minus 3? Because r is 3, right? 1 minus 3, which is negative 2. I want to slow down because that's a weird formula. Are we okay with everything that we put in there? Let's figure out this numerator first. Here's how I rock it out. Let me grab my calculator. I do the order of operations. Let's figure this part out first. 1 minus 3 to the 6. Did you get that number? Yes or no? I just typed in 1 minus 3 to the 6. Cool? What do I have to do to that number? What do I got to do to him? Times 15. And I get this. That's where I start writing some stuff down. I don't want to try to do it all on my calculator. I'm going to write down negative 10,920 over negative 2. Just kind of lets me know that if you punched the numerator incorrectly or not. That's why I asked you to write it down. Because if you only give me an answer, it's like, I don't know what you did. It's like, what was your numerator? You all good with that? Now, take that number divided by 2. What kind of number do you get, though? Positive or negative? Positive 5,460. So this means what? What did we just find here? If I took the first 6 terms, or I shouldn't say the first 6 terms, but these particular 6 terms, and added them together, wouldn't I get 5,460? Cool? Over here, find G sub 1 in the geometric series for where they give you all this information. Here's your nugget, right? Isn't that the biggest information right there? That tells you use this formula. Cool? So let's sub in. I know S sub n is 1530. G sub 1, do we know him? Do we know the first term? That's what they're asking us to find, so I hope we don't know it. Times 1 minus my rate, which is 2 to the 8th power, correct? All over 1 minus the rate, which is what? What's 1 minus the rate? Negative 1. Yep. Get rid of this stupid divide by negative 1 first, right? We're trying to solve for G sub 1, so I'm going to get rid of this divide by negative 1. How do you do that? So negative 1530 equals G sub 1 times, I'm going to go punch that in right away, 1 minus 2 to the 8th times negative 255. Right, yeah. Cool? I did 2 things at once. I got rid of this divide by blah, and then I punched in what was in the parentheses right there. And finally, G sub 1 should equal blah. Negative 1530 divided by that answer that I just had. 6. What kind of number should you get back? Yeah, it doesn't have to be a whole number. This isn't a term number. This is a value of a term. So you can get back a nasty number if you want to. Cool. So let's try it. 9. Set up all the ingredients. Look at the above problem. Figure out all the ingredients we need. If they want the sum of a geometric series, you better get these ingredients that are in the formula. You better get the first term, the rate, and the term numbers, right? Total term numbers. An R, an N, and a first term. So, first term that we are using. Please do this. Show me what you're doing. What? What's your first term that we're starting with here? What do we got? 54 or negative 54? What did you get? Right? What do you want next? R. It's basic. You can read it from the notation up here. What's the rate? Negative 3. And then N is high minus low plus 1. Aren't there 3 of those puppies? Use this formula now to add them up. We've got to be really, really careful. I turned you loose on this one, but what kind of number is the rate? It's a negative number. And you know what? People see this minus a minus all the time, and they think that should turn out to be a plus. It doesn't turn out to be a plus because it's something happening to that rate in this formula. Isn't it being raised to a power? So you must substitute it in like this. It's 1 minus the rate, right, to the third power. And when we want to punch that in, we better be very, 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 very careful. Now, some of you are going to get lucky here because you kind of punched it in wrong but still got the right answer. But it's 1 minus negative 3 to the third. I want that right there. 1 minus negative 3 to the third. I'll bet we get 28 out of that situation, right? Because negative 3 to the third is negative 27. And then you got 1 minus a minus 27. You with me on that? Okay, so 28 times negative 54. Boom. Negative 5. Tell me what that was. Negative what? 1, 5, 1, 2 over 4. And what's that turn out to be? 378. That's what I said. Cool. Let's do it again. Let's do it again. Ingredients first. Oh, I'm going to need 2 eggs. What? You said get those ingredients out. Starting with the first power. Don't you get a 0 for that exponent when you put a 1 in? And 4 to the 0th is 1. Take it times that negative 3. You should get negative 3 for your first term. R, you going to the mall today, is 4. And N is 5 minus 1 plus 1, which last but check, that's 5. 2. Put them into formula. Is the rate negative? No. We'll be in pretty good shape then. When we substitute in, we don't have to worry about all that crazy parentheses stuff. The sum is going to be the first term times 1 minus the rate to the nth power all over 1 minus r, right? What's 1 minus r? Slow down. What's 1 minus r? I think I'm going too fast for you guys. What's 1 minus r? Negative 3. You want to type all that stuff in? Or you want to simplify that first? Can you guys see anything that simplifies very easily? Isn't there a negative 3 upstairs where this is all times, right? You know, it's like you would and a negative 3. Don't those cancel each other out right there? And then you just got to punch in 1 minus 4 to the 5th. 1 minus 4 to the 5th. Negative 1023. Mr. Negative, you're too tiny. Feeling good, boss? 11. These will be interesting. You know, I can see that you're like, I get it. These are going to be interesting. Let's see if you can figure out why they're interesting before we get going. Discuss with Pal. Why are these interesting? No one could figure out what would be funny with these two problems yet, which is understandable, right? Because it's still new to us. But I can see it just clear as day. It's like something's funny here. So let's go through the problem and see if we can figure out as we go. First term that we need. Don't we put 3 in for k? So that's really a negative 1 to the what power? Second. What's negative 1 to the second power? Is 1 times 4. 4 is the first term that we're dealing with. Cool. R, negative 1. Number of terms, 10 minus 3 plus 1. 7 plus 1 is 8. Stop. Does anybody now figure out what's going to be funny about this? Someone noticed that the rate is negative 1. And they said, isn't the number just going to be the same? Will it be the same? What's the first term that we're starting with? 4, right? What's the next term after that going to be? Is it going to be 4? Well, what's the common rate that you're taking it times, the ratio? Taking it times what? So what's the next term after it going to be? Negative 4. Then what's the next term after that going to be? 4. Then what's the next term after that going to be? So isn't it going to go 4, negative 4, 4, negative 4, 4, negative 4, 4, negative 4? Isn't that going to happen? Because what's the rate? It's not a 1, though. It's a negative 1. Doesn't the sign change every single time? Correct? Well, let's see what happens if we add those numbers up, right? I'm going to add up all the numbers in this sequence. I'm going to add up a 4 and a negative 4 and a 4 and a negative 4 and a 4 and a negative 4 and a 4 and a negative 4. What do you think you're going to get back? Do you think you're going to get a 0 back? Well, let's just see. The sum of these 8 terms will be the first term, which was what? 4 times 1 minus your rate, which goes in parentheses, right? Don't put plus 1, right? It's 1 minus negative 1 to the nth power, which is 8, all over 1 minus r. What's 1 minus minus 1? What is it? 2. Cool. You want to do some reducing right away? Can you reduce the 4 over 2 to be what? 2 over 1, right? So it's like the denominator's gone. Now the sum of those 8 terms is going to be, well, let's see. It's 1 minus, minus 1 to the 8th. Before I even hit equals, what's negative 1 to the 8th power going to be? Positive 1 or negative 1? Positive 1, right? What's 1 minus 1? Take that times 2. What'd you get? Well, isn't that amazing that all those terms added up to be how much? 0. Cool. Next problem, baby. Next problem. Let's find that first term. We're putting 5 in. It'd be negative 10 times negative 1 to the 4th. Correct? Because we put 5 in for k. And what's negative 1 to the 4th turn out to be? 1 times negative 10, which is? Oh, I should put that here. Negative 10. Cool. Our first term that we start with is negative 10. What's our rate? Negative 1. Well, wait a minute. What do you think all these terms are going to add up to be? You feel 0? Well, let's go through the whole problem and see if they add up to 0. Because we need one more thing. What do we need after this? We need an n, which is high minus low, plus 1. Which is 10 plus 1, which is what? 11 terms we are adding up. Right? 11 terms we are adding up. Do you feel it will add up to be 0? Not going to happen. Why not? Because we don't have an even number of terms that we're adding up, right? Don't they go negative 10, 10, negative 10, 10, negative 10, 10, negative 10, 10, right? But every even group adds up to 0, but there's an odd group. So let's see, what do you think it should add up to, 10 or negative 10? Well, let's see. The sum of those 11 terms will be the first guy, which is a negative 10, times 1 minus that minus 1 to the 11th power over 1 minus minus 1. What's 1 minus minus 1? No matter what accent you use, it's a 2. Can you reduce the negative 10 over 2? And you get negative 5 over 1. Let's punch that in. 1 minus the minus 1 to the 1 power. Don't you get a 2? Times negative 5, which is? So, you see the sequence was the same number that alternates signs, right? It's just 10, negative 10, 10, negative 10, 10, negative 10. Odd number, it's going to add up to whatever your first term was. Even number of terms, it's going to add up to nothing if the rate is negative 1. Yeah. 13. Find G sub 1 for the geometric series described. See if you can do that for me. Use the formula from your Mint note card that you feel would be necessary based on the given information. Pause the video, give it a shot. The formula you should have used is this one. being as they gave you the sum of those first n terms. Did you get 18 to be the first term, yes or no? Cool. Is the next problem the same thing with the same information? Do they give you all the same ingredients? So wouldn't you do the same thing, right? You would use that formula. Next, 15. Discuss. Find 3 geometric means between 2 and 1250. We need to find something. What do I need to find to fill in the blanks? The rate. Cool? How can I find the rate when I have a geometric sequence? Like we had a cool trick before, number of blanks for the difference thing, you know. Not going to work. We need a formula. Which formula from your Mint node card do you feel you would use? Gordon. Can we use this formula? It's got an R with it, right? Do you have the information to solve for R? Do you know the number of terms? Yes. There are 5 terms, right? Do you know the first term? Yes. Do you know the sum of all of those, though? So we can't use this formula. What else do we have? We've got this. Let's see what we know. Do we know the first term? Yes. Do we know the number of terms, n? Yes. And do we know, like if n is 5, right, isn't n 5, do we know the 5th term? Yes. Can't we use this bad boy right here? So let's start with it, just so you have notes. When you look back, it's like, oh, I used the explicit formula because here's what I know. Let's do this. I know the g sub 1 equals what? 2. N equals how much? 5. And don't we know g sub 5 equals 1250? And if you want to call that g sub n, you could call that g sub n. But don't you know the 5th term is 1250? So substitute into this explicit formula, and let's find R, the rate. The first term, which is a deuce, times R, you're going them all to the n minus 1 power, so isn't that really a 4th power? Correct-a-mundo. What's our first move? Divide by 2, 625, right? Ha-ha! Now how do you get rid of the 4th power? 4th root it, right, by raising it to the 1/4 power. What's the 4th root of 625? Oh, are you sure? Are you sure that 5 is the only answer? 5 or what? Anytime you take an even root when you're solving an equation, isn't there 2 possibilities? That the rate could be 5 or it could be negative 5. Cool? So here's what we're going to do. Put yourself like 2 different scenarios here. Let's fill out the top scenario. If the rate was a positive 5, I want the positives on top. And the first term is 2. What's the second term? Is it 7? Why isn't it 7? I don't want to add, I want to multiply. What do you get? 10, right? Keep rolling. Come on, we can do this without a calculator. Times 5. 50 times 5. 250. Check it again. Times 5. Would you get that number back? Cool. Those are all the positives up top, right? Now what if R was a negative 5? We'll put those down below. What's 2 times negative 5? Negative 10. What's negative 10 times negative 5? Positive 50. What's 50 times negative 5? Negative 250. You see, it's going to be the same numbers, but just the negative guy is going to have alternating signs involved, and the positive guy, they'll all be positive, or whatever the sign was to start with your first term. Good deal? Shira time! Not Shakira, just Shira. Shira! She got a joke in an email that asked her to forward it to 4 friends. Yay, Shira. She forwards it, then each of her friends forwards it to 4 of their friends, and so on. If the pattern continues, how many people will receive the email on the 9th round of forwarding? So she forwards it to 4 friends, then those 4 friends forward it to 4 friends, then those 16 friends forward it to 4 more friends, and et cetera, et cetera, et cetera. So what kind of situation does this sound like? Arithmetic or geometric? Geometric. Cool. What is R? Isn't the ratio 4, correct? Do you know the first term in this situation? What is the first term? 1, right? She was the one person that got that email. Cool. Do you know N, the number of times that this happened? 9 times. Use the explicit formula to figure out the answer to this question. G sub n will equal the first term times that rate to the n minus 1 power. G sub 9 will equal 1 times the rate, which is 4, to the 8th power. 4 to the 8th power. 65536. 65,536 people get that email if everybody did their job. And of course, there's a flaw with this. What's the flaw that this doesn't mention? You send it to 4 friends, then you ask somebody else to send it to 4 friends, and they send it to 4 friends. That they what? Well, let's assume that everybody sends it on to 4 people, right? And they don't send it to more. Okay, that's cool. That's great to bring things up. First of all, you have to realize that they have to do their job and send it to 4 people, right? Then they can't do more than their job and send it to more than 4 people, right? They can't send it to somebody who's already got it also. It's like if I send it to Jeannie and then she sends it to 4 people, but one of those 4 people was somebody that I also sent it to. You know what I mean? It's like you don't want the repeat in the pattern also, to where you got that email more than once. Cool? So a lot of assumptions have to happen for that to really be the right number. Cool? Everybody has to do their job. You can't do it to more people, and you can't have overlapping. If the pattern continues, what is the total number of emails sent in the 9 rounds? See, this is how many people got it in round 9. Like, that's how many people got it in round 9. They're now asking you how many total people received it in all 9 rounds. Don't you need all of the people in the 9th round, plus all of the people in the 8th round, plus all of the people in the 7th round, plus all of the people in the 6th round, et cetera, et cetera, et cetera? What do we need to find for part B? The what? The sum of this geometric series. So that would be the sum of how many rounds did we have? The first term, which was? Times 1 minus the rate to the 9th power over the 1 minus the rate. What's 1 minus the rate? Negative 3. Cool. So that would be 1 minus 4 to the 9th. Two, 6, 2, 1, 4, 3. Did I write that number down correctly? Divided by negative 3. I hope it's a positive number, right? How many total people got it? 87,381.